So let's give this guy a go. Symmetry, factorize, asymptotes, intercepts, regions. I'll save you some time. I will tell you this graph has no symmetry. Okay? You can slap in minus x and it gives you nothing. Right? It's not very polite to you. Okay? So there's no symmetry we can take advantage of. No obvious one anyway. I'll save you some more time. You can't factorize it. Okay? Both of these guys have no solutions. They both have no solutions, the numerator and the denominator. If you let them equal 0, you won't get any real numbers out of that. Okay? We get complex numbers, but that's another topic. Okay? Literally. So because I have no symmetry, I have no factorization, that, by the way, kind of answers the last question for you already, right? In terms of regions, this guy is always positive, and this guy is always positive. So therefore, the quotient of those will also be always positive. Okay. So in regions, it's a bit boring. Okay. Now let's think about the asymptotes. Okay. Vertical asymptotes, because the denominator never equals 0, because you can't factorize it, there's no vertical asymptote. So that's nice. Okay. Now let's think about the horizontal or oblique asymptote that you would get out of this thing. Okay. The degree of these two parts, right, are the same. X squared divided by x squared. So as I approach infinity, okay, both positive and negative, okay, these 4s, how important are they? Not important. They just disappear away. These x's, they're kind of important, but they're not important when you compare them to the x squareds, right? No matter how enormous these guys get, the squareds will always be more important. And that's kind of why we look at the degree. The highest power is what takes over, okay? So they're the same. If I say, okay, x equals 1,000, this guy will be 1,000,000. And this guy will also be 1,000,000. So 1,000,000 and a little bit divided by 1,000,000 and a little bit will basically be 1. Right? It'll be 1, okay? Let's be a little more fine, and we say as x approaches infinity, okay, y is approaching, we've just said 1, is it coming from the top or the bottom? Okay, now, the way you can know is, again, like, we can do this analytically, but let's just try it out with a number, okay? 1,000 very large, let's just do 100, okay? What's this going to be? 100 squared is 10,000. That's what I meant to say. 10,000 minus, I put in 100, didn't I? So this will be 200 plus 4. Okay? On the denominator, it's the same thing, just I have a plus in the middle. 10,000 plus 200 plus 4. Now don't calculate anything. Just tell me which number, numerator, denominator, which one's bigger. The bottom is bigger, right? So if you have numbers where the denominator is bigger, like 4/5 or 7/8 or 9,999 over 10,000, are you above or below 1? And the answer is you are below. You are below. Okay? So therefore I'm approaching it from below. And because of how similar the numerator and denominator are, you can see when I put in minus infinity, I'm just going to do the other thing. Okay, just going to do the other thing. I'm approaching from the top. So I've got an asymptote. Let's put this guy in. Y equals 1. Y equals 1. There he is. Y equals 1. I know I'm going to be approaching from the bottom over here. Okay, and I'm going to be approaching from the top over here. That's all I know so far. Okay. Symmetry, I've factorized. I've worked out all the asymptotes, there's only one. Okay, intercepts. All right, let's give it a go. Intercepts. Now, before I do anything, you can see, right? Like if I don't have a solution to this, and I don't have a solution to this, right? There are no x-intercepts. There will be no x-intercepts. But I can put in x equals 0. That'll give me a y-intercept, right? When you put in x equals 0, 0, 0, 0, 0, you have 4 over 4, which is 1.
Wait. It's not a vertical asymptote, so
okay? It's a horizontal asymptote, so it only tells me about the extremities. So can I cross it? Of course I can. I have no problem crossing a horizontal or oblique asymptote. All right. I've gone through my whole process. You remember I didn't draw regions on? Do you remember why I didn't draw regions on? It's all positive, okay? So let's think about what this thing must do. Let's think about what this thing must do. I know I'm approaching from the bottom, and I've got to come from here. I'm going to come from here, okay? So, could I do this?
No.
Nope. Because I'm going to have to approach from the top, if that's the case, okay? Or I'm going to have to wiggle more times, and there aren't enough powers to get that number of changes, okay? So, no, I'm not going to approach, I'm not going to go up first. I'm going to go down. I'm going to go down. I'm going to do something like this. Okay. What else can it do? It has to go down. It can't touch the axis because it can never go negative, and it can never even have an x-intercept. There's no solutions there, right? And so I have to come back up before I get there and approach my asymptote, just like you expected. Okay? On the left-hand side, you're going to get much the same thing, right? It can't go down because remember, it has to be smooth, right? So if it's sort of doing this, right? And so it's going to be approaching like that. There's the graph. Now, I could stop. I could go home. You've gone through everything. You don't know calculus and differentiation, which I've alluded to before, right? So therefore, strictly speaking, these points here, like how high does it go? How low does it go? We don't really know, okay? So at this point, I would be happy to just say the question is finished, okay? However, oh yeah, we do need some points for scale, okay? However, I am going to press on this a little further because actually we don't need calculus to find these two spots. And the reason why I'm going to address this is because it addresses something we already know. Okay? So I'm going to push into something a little bit more advanced so we can take on a harder question and answer something you've already been asked about domain and range. By the way, domain and range, it is accessible. Okay? You'll get it with much easier functions. But there's no reason we can't do it with this. Okay? So here we go. This is the hardest part of what we're about to do, but if you can hang on to your hats, you'll see something I think it's quite mathematically beautiful. We can do this and not need some really, really hard maths. First question, what's the domain? This is the easy part. What's the domain? All real values. I can go everywhere. All good, okay? What about range? What about range? Clearly, I'm restricted in somewhere. Right? So it's going to be like y, right? There's got to be greater than something and less than something. But the question is, what are those? Like, can I find out what they are? If I find out what they are, then I have these positions, right? Because that's the highest spot, and then my range is below that. And here's the lowest spot, and my range is above that. Does that make sense? Okay, so how do I do this, right?